Hi, everyone. Welcome to the webcast today. I'm Torey Penrod-Cambra. I'm the Chief Communications Officer at HighByte, and I'm your moderator for today's panel discussion. So I'm excited to be here today with my colleagues, Jeff and Aron. Aron will be on his way shortly. Of course, what would be like an office hours or a demo without technical difficulties. So I'm going to go ahead and get us started, and then Aron will join shortly. And I'll introduce our panelists as well. So Jeff, who is not having technical difficulties, at least not yet, is a product manager at HighByte. He's focused on product positioning, technology partnerships, and reference architectures. He's an experienced technologist who brings more than a decade in technology leadership roles in the automotive and discrete manufacturing industries to his role at HighByte. And Aron is the Chief Technology Officer of HighByte, focused on guiding the company's technology and product strategy through R&D, technical evangelism, and supporting customer success. Aron has more than 15 years of experience in industrial technology and will be joining us shortly. So let me go ahead and share this with you. We'll just begin with, go back to the beginning here, some housekeeping items. There we go. All right. So this webcast is being recorded. It will be shared via email with all of you in the next 24 hours. You can use the Q&A tool to ask questions during the webcast, and our colleagues Ryan and Ty are online and ready to answer your questions. So hopefully we'll also have some time at the end of the webcast for a live Q&A with the panelists. As a brief introduction, we're here today to discuss and demonstrate how to build APIs for your industrial data, and we'll talk about why this is so important. We'll also introduce you to other new capabilities in the latest release of the Intelligence Hub, with 4 product demos that bring this discussion to life. For those of you who are new to HighByte, I'll give a quick introduction. At HighByte, we're on a mission to provide manufacturers with the data infrastructure and data contextualization needed to get digital transformation projects out of pilot and into enterprise-wide production. With more than 400 global deployments, our proven industrial data ops software, HighByte Intelligence Hub, is helping us accomplish that mission. Since founding the company in 2018, our customers now span 24 countries and 20 vertical markets, including life sciences, automotive, pulp and paper, oil and gas, and many more. So what is HighByte Intelligence Hub exactly? It's a data ops application built for industrial data and deployed at the edge. The Intelligence Hub delivers modeled, ready-to-use data from any asset or system to its destination using a low-code, no-code interface to speed integration time and accelerate analytics. The Intelligence Hub, you can merge machine, transactional, time series data from a wide variety of sources into a single payload. You can standardize and contextualize information models in real time. And as we will discuss today, you can leverage publish, subscribe, or request methodologies for accessing your data. So let's get into it. For the next 55 minutes, we're talking about how to use the Industrial Data API Builder that's new in version 4.1 to quickly and securely build APIs for your industrial data. We'll also be showing some tips for testing, debugging, and troubleshooting your data pipelines. We'll talk about why and how to build an open transactional data lake using the Intelligence Hub new native integration with Amazon S3 tables. We'll talk about unlocking data stranded in file stores because we know you all have it. And we'll also discuss support for highly regulated industries like pharmaceuticals and oil and gas. And that includes everything from native connectivity with Aspen IP.21 and PassX to Granular Audit Logging, all new in the latest release. So obviously we've got a lot to cover. So we're going to go ahead and get started. And I'm really excited to see that Aron is joining us.
Can you hear me?
Yeah.
I had to reboot my whole PC, so I'll try to get ready for the first demo as you guys go, but just glad to be here.
It wouldn't be office hours without excitement. This is just par for the course. Great. Okay, so while you take a breath, Aron, let me direct the first question to Jeff. Jeff, we added a lot of new capabilities in version 4.1. We call it a minor release, but it didn't feel like one, including the Industrial Data API Builder. So what is this?
Excellent question. Let's go ahead and get started. So pipelines, for everyone who is new to Intelligence Hub, pipelines is kind of the center of data engineering, or it's really the center of the Intelligence Hub. Allows you to sequentially process data. But what I think is very telling or is interesting is pipelines just kind of, I think, hit about their 2-year birthday or 2-year anniversary, if you will. Came out in version 3.0 and kind of first started as, I kind of consider it post-processing, right? So after Intelligence Hub built constructed data models or data structures, there's now an ability, we're finding that people needed different types of data consumers within the enterprise that needed data structures shaped a little bit differently. So that could mean flattening data structures, breaking them up, buffering them, and so forth. And with each subsequent release, we added more and more capability, and it's remarkable the things that Intelligence Hub users have accomplished with them. But over time, there's been broader ambitions, and one particular feature came out in 3.1, which I'll get to in a second. But when people think about pipelines, it's very powerful. There's lots of processing capabilities. But what people have wanted to kind of over time is to think, this is really great. What if I could wrap this up as like a data service and invoke it? And that is largely motivated by a feature that came out in 3.1. And that feature in 3.1 was the REST data server. So it also level set on the REST data server, because it's sort of interesting. We have like kind of two parallel features finally meeting with each other, right? The REST data server is essentially an API that exposes the data plane within the Intelligence Hub. So if you make a connection to a bespoke factory system, right? People don't know, when you leave the factory environment, they don't know what things like OPC UA are. They don't know what Aviva Pi system are. They don't know what Sparkplug is, right? Up in the enterprise, generally HTTP kind of rules it all, if you will. So the next thing that people, when they first got their hands on this feature, right, they said, this is incredible. Can I build my own custom endpoints? And that's exactly what we've delivered here in version 4.1. Pipelines have now been exposed to the REST data server as an endpoint. So pipelines, because they tie together all the different data sources, all the different modeling and data processing within Intelligence Hub, users now can build APIs for their business processes, for their applications and services.
Thanks, Jeff. That was really helpful. Okay, so that's a good explanation of what, but I guess my next question to you will be sort of the why behind that, right? Like, so what are typical use cases for the Industrial Data API Builder?
There are many. But I go through. So I'm going to go through just a couple of speed rounds for different scenarios, and we'll touch several different industry verticals. So the first scenario is we'll take a life sciences example. You know, Pi is very common in life sciences. You have instrumentation, you have asset data, right? But I often think is that the more sophisticated the manufacturing process, the more sophisticated the automation, the more important the role of people are, right? If you don't have people maintaining equipment correctly or setting them up correctly, that automation is not going to do its job, right? And so Tulip is an excellent platform for kind of coalescing that world of automation and the work that people do in a manufacturing environment. But imagine if you're, let's say, you're doing you're at a different phase of a batch, or you're doing work orders, or you basically need to collect data. Maybe you're doing your electronic batch records within Tulip. What's quite nice about this new REST data server is a lot of telemetry data or a lot of instrumentation is routing through Pi, right? But you may not necessarily need to know when you may not necessarily need to acquire that data always, right? Maybe the machine is down, or maybe you're in maintenance mode, right? You're still logging it because process engineers might be interested in that data. But for those who are maybe doing quality work, or those who are maybe more integral to the manufacturing process, right? It might be advantageous to be able to hit a command in a Tulip app, invoke a request down through the Intelligence Hub, and pull that data out of Pi and log it to a batch record, as an example. Another scenario could be, I call these IT/OT turf wars, right? You often will have a lot of SaaS applications that maybe have specific APIs on them, right? And sometimes there's not quite the level of granular control for access control, right? There's also multiple endpoints, right? The lower you go down the factory stack, the more primitive that those systems want to consume data. So it's not ideal to basically give someone an API endpoint that requires them to paginate through 10 pages of records or iterate through 3 API calls sequentially, right? But also this also creates versioning issues. So instead of people kind of having conflict, right, in terms of trying to figure out what can I expose, what can I not expose, you can have a federated model where you could essentially wrap enterprise data services with the Intelligence Hub and expose them as an API that's perfectly curated to the needs of OT. Another scenario could be something like file systems, right? A lot of systems let's say in your quality labs or even instrumentation. I've seen it recently, welding and robot data recently dumped into log files. Those aren't event-based data sources. They're just crudely logging to files all the time, right? And what the data consumers don't want is they don't want a backup of files from the previous day. They want to monitor those files in real time. So by having an API builder, you essentially could build a protocol or align with the access patterns that users need. Another scenario could be UNS, for example. UNS is incredible how it's democratizing data access. People are getting real-time visibility and access to all the current events, right? But over time, as people build out more and more use cases, data starts propagating different corners of the enterprise, right? And it might be problematic to say, hey, just to only have one interface just for the current state is enough. People might want to transact with those things. They might want historical data and such. So another approach is I can wrap these different data sources or my entire UNS with an API, and I can make that available and curate it to different users. And finally, another scenario is AI, right? AI is hot. There's lots of interest in it, right? But there's also a lot of concerns. There's concerns over privacy. There's concerns over latency, right? And also there's a broader concern just about the efficiency, right? I think if you're going to the cloud, right, that's going to be a variable cost resource. And so you want to be very judicious with how you use compute. But if you're going to be also doing edge AI, you might also want to consider that's finite capacity. So you also want to be judicious with your compute, right? Having the ability to wrap AI function calls in different data sources, so you're getting precise queries and you're feeding that data in a very thoughtful manner makes a lot of sense. So in other words, there's no shortage of APIs in an industrial environment.
Awesome. Thank you, Jeff. That was really helpful. It's helpful to see tangible examples and to sort of bring that further to life. Aron, I'm going to cut over to you. Like what would it look like to experiment with AI at the edge, and how would you use HighByte Intelligence Hub to do that?
This is demo. Is that the demo queue?
This is the demo.
All right. I'm just happy to be here. That was quite the excitement. I swam this morning, so my hair's a mess. And then I came in and the earbud on my ear set was just broken. So I had to switch ear sets, and I think that was the cause of the whole thing. But let me know when you can see my screen.
It looks good, Aron. Yep.
Can you see you can see pipelines? Yeah.
Yes.
We're in. Okay, so I want to talk about the API builder specifically to Edge AI, right? So to start, what I'm going to do is if I just go to ChatGPT and say, what is the weather in Portland, Maine? Now, we all know that they're not training this thing every day, right? Like we didn't train the model. This is months old model that we're running, so they don't know the weather. The ChatGPT doesn't know the weather today. So what it's doing is it's doing something called function calling. So it knows that when I ask for the weather, it's going to reach out to an API that will return weather data. It's going to process that data and then obviously show some nice icons and present that to me in a nice way. So I'm probably not the first one to ask this of ChatGPT because it looks like it's a pretty polished response. So the same thing applies in manufacturing, running LLMs at the edge, right? This concept of function calling is I need to be able to ask questions to the LLM. It's not going to have all the information. It needs to reach out to specific endpoints to gather that information in the factory. And the API builder allows you to do that. So let me show you the end state, and then we'll kind of work our way backwards. So this, you probably saw a previous video I put out that kind of walks a little more in detail of how this is working. But this is not part of the HighByte product. This is a demo I created. It's a separate app that's kind of mimicking what ChatGPT was just doing, right? So I can say, what does my factory look like? And it returns a nice namespace with different paths. go read the current data for the crusher. It's calling into HighByte, returning the data, and it's not putting all the nice little icons like the weather thing, but it's returning it in a format, right? And I can ask for averages and things like that. So let's dig a little bit more into how I enabled this app to do this. So in HighByte, the first thing you need to do is you jump in and you turn on the REST data server. So that's under settings. Once you enable that, I was trying to like rebuild all the demo stuff after my reboot. So there's probably a few things we're going to have to struggle through as we go through, but it'll be fine. We have a Swagger UI that'll show you what that API looks like. And as that loads, really there's 2 new endpoints that we added to it that are around pipelines. If you scroll down here, the first one is you can get a list of all the pipelines that we internally refer to as callable, meaning you can call them from the REST data server, and then you can call into those pipelines. And you can actually exercise this here, but I'll show you different places you can do it in the product. So I have pipelines that are enabled. They're enabled now over the REST data server. That's what that LLM that I showed you is actually calling. So in here, I've kind of organized some pipelines for the demos. This one's all the edge-based API pipelines. And actually, we had an error. So we'll go see what that. Oh, aha. I'm not running my SQL server. That makes sense. All right. So that's up and going. So we're good. But okay, the first one I asked is, hey, what's the factory look like? So if we go in here, what's different now from previous versions is pipelines, they were triggered, they did some processing, and they sent data. That's not what this pipeline is doing. This pipeline is being called by a client, in this case, the LLM that I showed you here. It's doing some processing and then it's returning data, right? So if you look under stages, under control, we can now have a return stage and error stages. So I can actually respond to the caller with the payload. I'm not going to move the data somewhere else. So in this case, I'm using what we call Smart Query. I won't go into the details of this one, but I'm just saying, give me all the paths on my namespace and return it. And if we jump here quick, just so you can see the source of data that I'm pulling from. Prior to the demo, I built a namespace in HighByte that's just a fertilizer demo. You can do a test read now in the namespace view. So if I pop that out, you can see this is the data that's there. And I'm just running this Smart Query thing in the pipeline to be able to get the data that I want. So a really cool feature that probably made this demo, took half the time it normally does to develop all this, is pipeline debug. So what I just did is I put the pipeline in a debug mode. And what I'm going to do is I can inject whatever data I want in the pipeline. In this case, this one doesn't take any quote unquote parameters. So I'm just going to leave it as the default. Doesn't really matter. But when I hit run, it's actually going to execute this pipeline and show me step by step what it did. So you can see at this stage, in came the input value that I didn't change. I just left that as is. And when I did the Smart Query stage over on the left, on the right, you can see this is what came out of Smart Query. So value is just events and pipelines have values and they have metadata. So this is what would go out over the wire if we were to send this somewhere. And then metadata is additional data that we could use. But then what I'm doing is I'm just returning the value. So I'm returning, this is exactly what I'm returning to the LLM in this case. And then it's taking this and doing the inference to say, well, I'm not going to show you the path in the raw JSON. I'm actually just going to, format it a little bit and show that to you. A little more complex example is like get machine data. So here I actually need a path. So if you look in here, what I'm doing is that the LLM is actually passing one of the paths. When I said, go get me the crusher data, it's passing in the path to the crusher data. And to see that, I think I already had it on. Sweet. So I can look at a replay of when we just ran that earlier. And we're in 4.2, we're going to rework replay to be the same as debug. So you get that same view, but it's still fun. It's just as functional. So let me go back into replay. And here, as I click around, you'll see that what came in is the path, right? So the LLM actually passed me this JSON. I went in and used that to go read the current state of that crushing machine, and then I just returned the data. So this is a really simple pipeline, but it's an example of the LLM can also pass parameters into the API that we can then leverage to make these pipelines a little more dynamic in terms of what they can do. The last one I want to show you that's in there that I think is pretty cool, I nerded out when I did this one, was there's one that returns the average data. So how am I getting the average? How am I getting the historical data, because we don't have an historian? So what I did is, in Docker, I spun up an influx database, and it's called Nice. It's got a default name here, but this is InfluxDB. And what I did is I have another pipeline out here that I'm calling edge processing. And what this is doing is it's going every 5 seconds. This is our traditional pipeline. Every 5 seconds, it's waking up, it's going and reading that whole namespace, and it's logging it to Influx. I'm doing a little bit of translation here. I'm pulling out non-numeric values because I don't want that in there. And then if I jump into Influx, what you'll see is that namespace that I showed you, this, right, is getting logged directly into Influx. And I just want to see all the data. So if I submit this, you can see here's this historical data that's getting logged. So I'm logging my namespace into Influx. And then through the API now, back out. If I go to the edge, when the LLM asks for get machine data average, what I'm doing is I'm using that, it's asking for the crusher. So I'm going and getting that information. And I won't get into the gritty of this, but I'm basically passing the path into Influx and the model information because Influx needs that too. And I get the average out. And let's just run this through debug. We may need to struggle. I'm just going to create a path here. Portland, line 1, crusher. So if I run this through debug, we can actually see what it's doing. It's going to query the namespace, so it needs this path and model information from the namespace in order to effectively query Influx. It's going and reading the averages. Influx returns it in this format, and there's a Flux query that I'm passing this into, but this is the default return of Influx, which I don't want to pass on to the LLM because that's a little too much information. So I'm using a little transform stage here to rip this out and say, give me the field name followed by the value. And what I actually return to the LLM looks like this. So it's just 10-minute rolling averages. What's cool about this is I can take this and go factory to factory. And if a factory has Pi, right, I can keep this API layer the same. And I can just change this query to go reach into Pi and do the same thing. So it gives you that layer of abstraction, which is super cool. And it gives you the ability to quickly iterate and play around with these LLMs because it's a very iterative process. I can create endpoints on the fly, change the information I'm passing the LLM to try to get better responses. And I think if you're involved in anything like that at the edge and LLMs, and you're interested, ping me. That's kind of my life now. In the current moment, I think that's where a lot of the innovation's happening. And we're just excited to be there.
Aron, that was slick. That was slick. I couldn't tell that didn't look like a reboot situation at all. Right, that's right. Good. That's great. I'm going to go ahead and launch a poll. Let's see. Maximize this so you can see it. What challenges? So Aron just showed us how to make things a little bit easier and how to do some experimentation. But I'm going to ask this group, what challenges are you currently facing in your company related to the implementation of Edge AI solutions? So I'll give you a couple minutes to respond to this. There are a lot of options in here, but we also came up with a lot of challenges, as there seem to be. So everything from agents that are focused on industrial use cases, cost, of course, whether that's cloud or edge compute, hallucinations, just buy-in from leadership, data governance, security and privacy concerns. Please take a moment to think about this in your own organization and respond. And then we sort of all get the benefit of learning from each other. And I will just add that this question actually isn't from us. I want to thank Lal Babu at Novartis for submitting it. I think he intended for us to answer it, but instead we're putting it back on all of you. So interesting to see some of these come in. The leading challenge right now is actually lack of data strategy, buy-in from leadership. It's interesting because even as technology obviously evolves and the technology might be in place to accomplish some of these more advanced use cases, it's people and culture still eat technology for breakfast. So yeah, that makes sense. The strategy is still leading ahead in data quality. No major surprises there. Okay, I'm going to go ahead and minimize this and let us jump back into the session. So we went through some use cases. Aron did a pretty sweet demo. A couple questions came in from registrants around the topic of Edge AI. And so I'll start with this first one that came from Avijit from TCS, which is how much human intervention will be necessary after moving towards AI-supported data analysis at the edge and on cloud. So Aron, you want just a couple minute answer on that one?
Yeah, I think the quick answer is still a lot, right? I think all of our experiences with LLMs in our daily lives tell that they're not always super accurate. So taking the human out of the loop is still pretty scary, I think, especially when you look at industrial. And the other thing that's going on is I think the initial success of edge-based LLMs in factories are going to be really specific, right, to specific use case. So it's like VAT machines in pharma. So you really need experts in that area that understand those processes and systems to help iterate and play with LLMs to get the results out. But I think, companies that are starting with big questions like how do I optimize my entire production planning and just feed it a bunch of data and try to figure out are probably going to struggle. Companies that focus on like smaller use cases, like I'm just going to monitor a few data points or the status of this VAT machine and try to tell if it's going to fail or not, based on additional information. I think the success is going to be very in small verticals, deep in small verticals, and it's going to grow out from there, which is going to require a lot of human involvement to find those successes.
Thank you. All right, I'll jump to the next question, which is in the same vein, but a little different. I really like this question from John Andreas at Good Tech. And so he asked, I think that pushing your data to the cloud to get AI capabilities is a hype. Would you say that edge AI is the way forward to get value from your data faster at a lower cost? And Aron, we can start this one with you, but I'd like to hear from Jeff too.
Yeah, my answer is quickly yes. I completely agree with. I don't think it's hype. I think there's a lot of value still in AI capabilities, kind of through the full stack. But I think specific to manufacturing, the most value is going to be driven at the edge with experimentation and LLMs, totally edge driven, run at the edge, data provided at the edge. So, but Jeff, go ahead.
Yeah, I think to piggyback on the whole, we'll call it micro use cases versus macro use cases, like production planning versus some sort of agentic thing, right? If it's focused right, you'll probably have better success. And I think Edge has a lot of potential there. But I would not necessarily rule out, I wouldn't strictly associate cloud with cost, because you could just, if you're not being smart about your data strategy, right? You're going to have to over provision compute. Or your LLMs at the edge aren't going to go that well. So I sort of view it as there's a place for both, but I think really to get the value out of things, right? It's a combination of having a sound data infrastructure, so you're feeding things in a smart, prescriptive way, but also you're focused enough, right? It's not saying, hey, let's just dump a bunch of data and pray that something useful results.
Nailed it. Okay, thanks, guys. So I think we've hit our daily quota of saying AI. So not everything is AI, right? We all have a lot of other challenges and certainly projects on our mind. So getting back to the API builder a little bit, what else can you use the API builder for? And Aron, I'm going to shoot this over to you and to kind of queue up a second demo here. And I think this also gives an opportunity to show off the new connectivity with Aspen IP.21. So I'm going to turn it over to you.
Yeah, let me know when that comes up. What is cool, one last AI thing, Torey, I'm sorry, I can't not. But what was cool is it actually reported the error back when I asked for the work order. That was the error we were seeing in HighByte. And if you go into that run, you can see the error return. So it was able to infer, give what we gave back, that there was an error, and then I was able to track it down. And I think if we just debug, this will fix it, because I turned on, basically SQL Server was down. Green, all right, we're cool. So it should know what this is now. Sweet. All right. Anyway, okay, enough of AI. That was it. I just had to show. That was cool. So we added an IP.21 connector in 4.2. So IP.21, if you're not familiar with it, it's a historian, right? So you can think of it like a Pi, like a GE prophecy historian, wonderware in SQL, but very specific, used more often and not than batch. So we have connectivity to that now. If you're familiar with our Pi connector, it's similar in the sense that it's an agent. So the primary way to connect to this is over ODBC, which is not a Java native technology. So if I jump over to, I think this will work, to the system we're hosting IP.21 on, we have a agent like we do Pi, and the user guide covers all this that you set up, and then we connect to that, and then we can communicate to this through that agent over basically it's a SQL syntax. So if you've never seen IP.21, this is kind of what it looks like. These are tags that are in IP21. And then in terms of the syntax, I just pulled up the help guide here, and you'll see it here, right? It's SQL-like, it's super powerful, but it's a little bit complex for a new user. This probably took me the longest in the demo to be able to figure out these queries that I wanted to write and get those working. And I did kind of laugh. You'll see the example in here is from 1997, which just made me, I mean, that's the industry we're in. So,
we just transitioned from AI to 1997.
Yeah, right.
Okay.
It's a wide gap. So let's just say one of the challenges with IP21 is if you have it, right, people want access to the data that's in there. It's very valuable. It doesn't have a ton of interfaces. ODBC is the best. Performance-wise, it does have an HTTP interface that's just ODBC SQL queries over HTTP is all it is, right? So your users are writing SQL queries. If you're an admin of IP21, the challenge there is first your users have to figure out what the SQL queries are, which are really very little documentation outside the one I was showing you. And then B, they're probably going to brick your IP21 server pretty quick, right? Because they're going to write massive queries that I think IP21 processes those serially. So the whole point is I want to expose this data to users and give them some control, but I can't expose the whole thing because I'm just going to be chasing down issues all the time. So how do I do that? So in this example, what I've done is I've created 3 inputs off IP21 I want to be able to provide the latest data for a tag, the history for a tag, and rolling average. And if you just jump in here quick, it's, you figured out this SQL syntax. I've parameterized these, so I'll show you where I'm passing in the tag name. So you'll see that syntax in there, but that's the latest one. History is a little bit more complex. You need like a start and an end time, where clause and all that. And then average is probably the most complex where I'm trying to do a rolling average over 10 minutes. But I don't want my end users writing this. Like I want to keep them out of this interface. So what I'm going to do is I'm going to use the API builder to build a standard interface to that data. And I'm going to call that, I called it the IP21 API. And for each one of those inputs, I've exposed an endpoint. So we'll start with current value. So in here, the contract I have through this API is you provide me the tags that you're interested in, and then I'm going to return you the latest value for the tags. So there's a little processing in here, and I'll run debug so you can see this where I'm trying to format the tags they pass in. So they're in more of an IP21 format for the query. And then I'm querying, going out and reading that input and passing in the tag values. And then I'm doing a little bit of formatting on the output because you'll see that the format's a little weird. So let me jump into debug. And this is where I had these all queued up. All right, so we're going to. So I'm gonna. This is essentially if someone's going to call this. This is what they're going to pass in. They're just going to pass 2 tags that they're interested in. I'm going to run this through debug. And what you'll see as you step through here is, okay, the tags come in. This parsing stage that I have is trying to put it in a comma separated quoted syntax for the query. And there's multiple ways I could have done that. This is the result from the query. So you can see it's passing the name, a value, and a timestamp. For this case, I don't necessarily care about the timestamp. I could include that, but what I'm doing in the format stage is I'm just making this name value pair. So it's the tag name and the value, and then I'm returning that through the API. And then if I pull up a client like Postman, let's go to this one. You'll see I basically just copied that syntax, and I'm going to call that endpoint that HighByte's hosting. And this is your consumer that wants the data. This is what they would do. So they just know I pass in the tags I want, I get a result back. And these happen to both be 8. And that's it. That's the contract so they didn't write SQL. They didn't have to know anything about IP21 other than passing the tags you want. I'll give you back the current value. In this pipeline, I could put limitations around like how many tags you can query, maybe say 100 at a time or something like that, and have an error return if you try to go. So I could start to put in that logic of how I want to put guardrails around this to limit that. The other one that's in here is a history query. So this one, I think if I paste that whole thing, this one's a little different in the sense that it's going to take the tags and then the time range. You can see I'm actually asking for a whole day's worth of data. So it's a pretty substantial amount of data. So it'll take a second to process. But similar to the other one, I'm going to pass in the params. I'm doing a little bit of light parsing there. I'm passing the timestamps pretty much as is. And then what comes back from IP21 is this kind of array syntax of each value with the value and the timestamp. And then I didn't do anything here. I'm just going to pass that back to the return. So even the latest tag is in there, but I could strip that. So again, I can go out to a remote client. I can pass that exact same thing in. And all I know as the consumer is I pass in the tag names, I pass in the time range I want, and out comes the data. And it's a significant amount of data. So I think Postman is going to. potentially struggle. It was working before. I think I host post month. We'll come back. It'll recover. But yeah, and then the last one was just is a rolling average. I could probably expose a browse API, right? So I could see the tags that are in there as well. But the cool part is that the consumers no longer have to have direct access to the IP.21 system. And I also don't have to make assumptions about what they want and just like publish raw data into a UNS or a bunch of data into S3. They can come and serve themselves and request data. So it's just another example of using an API strategy to wrap an older piece of technology and be able to consume it in a new way.
Yep.
And as an admin of IP.21, I would love this.
Aron, it's also interesting to me how central pipelines has become to the intelligence hub and so much of where I feel like our users are spending their time.
Yeah, and I think that's the last of the API builder will show. I think you'll see us enhance that farther in future versions, where there might even be an API section over here where you can define endpoints and parameters and kind of wrap that up. But this is our first iteration, and functionally, it's all there. As you can see, you have complete control. So we're pretty excited.
It's awesome. Thanks, Aron. I'll jump back into content. All right. Let's shift gears a little bit. I have a couple questions surrounding connectivity. So as many of you know, we added support recently for Amazon S3 tables. So I thought this was a great question. Came in from Dave, and he asks, in which manufacturing sectors have you seen interest in Apache Iceberg, and what attracts them to Iceberg? So Jeff, I'm going to hand this question over to you.
Great. Let's first level set what Iceberg is, and also level set, because sometimes we don't have users that are familiar with data lakes and such. And also, we're going to maybe fast forward maybe 10, 15 years past 1997 to an era when people used to say big data, almost kind of similar to the way that people talk about AI, right? If you remember back then, people were talking about, you've heard technologies like Hive and Hadoop and such, right? And it's kind of a science project to get data in and out of data lakes back then. It's kind of reflecting upon this technology. Things have gotten a lot easier, right? And it's even more incredible that like plant floor personnel can interface with these like very, very powerful systems without much friction, right? But to quickly level set for those who haven't kind of explored that part, and this is one of the most common solution patterns among Intelligence Hub users, is they're often landing data directly in a data lake. And a data lake at a high level is you're generally landing some sort of like text files or semi-structured text files into an object storage service such as S3, right? And there's some considerations that you want to have around there, right? You want to be efficient on there. If you overpack files or if you kind of underpack them, right, you could waste a lot of compute. And it's kind of a similar story to like AI, right? If you're not smart about how you shape and deliver data, you can sort of generate waste. But we're also doing things like converting to a Parquet format. Parquet is a columnar format, right? So if you think about a lot of manufacturing use cases like Aron just did, he was doing averages of values, right? Aggregates are really, really common in manufacturing use cases, right? So it often makes sense to take the values of data sets and kind of pack them together to make them efficient to query and such. But this works pretty well, right? And this is kind of how people kind of first started 10 to 15 years ago. But as you started building up these very, very large data stores, right, there became challenges at querying this and also evolving the schema, right? What you would have expected the data files to be may have evolved over time, and people were maybe having to rewrite stuff or retransform things. So since then, open table formats such as Apache Iceberg have started to proliferate this space. Seems really, really overwhelming that there's lots of the files there, but basically think of this as these are pointers to that data files. They describe the contents of that data files. They describe what's in there. But every time that we make a change to schema or we insert data, we're basically making snapshots, right? And by kind of cataloging all the different data in our lake, we now can effectively query it, and we can it can function more like a database, right? It has a lot of those qualities like acidity and such, right? But one of the other amazing features about Iceberg, right, is that it enables cross-platform data sharing, right? One of the issues that we're starting to see is as organizations become more data-driven, as they see data as strategic, as they see data as an internal product that they like to manage, they're finding that they have lots of different data consumers, and it creates a governance and management, even a cost issue, having too many sets of data in too many places. And we're starting to see by some more digitally mature organizations or organizations that are very advanced in their thinking about data, that they might want to centralize that data, right? They might want to have their data scientists work in Spark or Databricks, but maybe their data warehouse or business intelligence people work in Snowflake, or maybe they're doing experimentation with ML and AI and they have their own apps, right? And it probably doesn't make sense to have those different data sets proliferate across the way. And this can be done today with existing services, right? But it does require kind of cobbling together several types of services. Following down that path of things getting easier, it's not a science project like it was 10, 15 years ago. Amazon or AWS recently introduced a service called S3 Tables. It's essentially a new bucket type. It's basically a managed Apache Iceberg service, and we've built out a native integration to it. It's serverless, it has direct integration, and it can do schema creation. So essentially you can interact with a transactional data lake, 3 levels of different services as if it was a very, very simple database.
Awesome. Great answer. Thank you, Jeff. I have another question actually related to connectivity, a little different though. I know a lot of work went into files connectivity in version 4.1. Can you tell us about these updates and why they're so relevant for our customers? And Jeff, I'll take this one back to you if you don't mind.
Sure thing. So when I think of files, I think of 2 things, right? But first of all, I want to first emphasize that when people get down into we'll call it their data journey with industrial data, I think it's really, really important to raise questions about all the different types of data and the potential value that they yield. I've seen scenarios before in the past where a production line is ramping up. It may not even be at capacity for another 18 months. But right now, the current focus might be getting a stable process, getting a capable process, getting an economical process, right? So OEE is actually, things like OEE or tag data is actually not all that relevant, right? The data may be coming out of your quality lab, or the data of how you're offsetting your machines might be actually more important than just typical asset telemetry data, if you will. So there's a lot of value. There's a lot of valuable data locked up in files, but there's 2 problems that we generally see with files. A lot of systems just dump to data stores, if you will, and it creates a problem of saying, which file do I need to read? A lot of people want to monitor files in real time as if they're event-based data sources. But a problem is that you might have scenarios where a machine or a data source might open up a file when a certain program is ran, and it might continually append it, or it might do that once a day, right? And the problem is you want to be able to monitor that in real time, right? You don't want the data next week or tomorrow after those data sets have been complete. So it creates a problem of, what do I read? Our solution to this is one, we can obviously connect to these different types of data sources, right? But we've added directory browsing, right? So sometimes in production environments, you don't necessarily have full visibility of the native system, right? Maybe it doesn't provide browsing, for example. So we provide the ability to be able to reach in and look at that. But we also provided the ability to monitor the contents of that file, right? So we could see, are the file sizes growing? What was the last file that was modified? What was created and such, right? So we can pick up on those things. And then the other thing is that we also can take the binary and bring it in into different text formats. The second problem is, once you find the right file that you need to read, so meaning what was recently appended, there's a problem of saying, how do I read that file? Right? There could be other problems inside of that. You open it up, it looks like a complicated base 64 string. It's binary, it's very, very difficult. So we've added a lot of capabilities in pipelines to process file data. So one, we could make reads and monitor the file directory, but then the next step is, once we find the file that we want, we can open it up we can automatically parse things. If it's ambiguous, we can manually specify things. If the data is unlabeled, so meaning like the third column doesn't have a header on it, how is a data scientist or how is AI going to know that the third column is the robot position on the third joint, right? So it's really, really important that you have to contextualize the file data itself. So providing a lot of capabilities within pipelines to make that data usable.
Awesome. Thank you. I'm going to take the file question and actually point it back to our attendees and ask them, where do you encounter file data in your operations? Encounter is kind of a funny word, but we couldn't think of another one. It sounds like a chance meeting, but where
it's always a surprise in the industrial world.
That's probably true, Jeff.
Sounds like the starting line to a book. So I opened up a CSV file, and then
sounds riveting,
right?
So we have some options: 3D printers, applications, CNC machines, metrology equipment, vision systems, maybe other. I'll let that run for a second. And Aron, you'll have some breathing room because I am going to turn it over to you next for a demo. Enough talking about files. I think it would be fun to actually take a look at what we've done, what the R&D team's done. So I'm going to go ahead and close this poll for now, or minimize it. Everyone can continue responding, but I'll close it shortly while Aron, you want to jump into the demo?
Yeah. Let's do it. All right. So in this, so we added a bunch of capability to the file connectors, and I can't cover all of it, but the file connector's been in there a while. You basically just set a root directory. But some of the differences are, initially what we have here, we've added, before you could just read files. Now we have a type of input called a directory input. So with this, what I can actually do is I can look at what's in a directory, kind of like a browse, right? So remind me to put this back for my demo. But if I just do a test read, I've got a directory. That directory over here has, 4 CSV files in it. That's the one that I'm pointed at. And you can see when I read that, now I have the name of the file, creation, and some metadata around it, the size of it, creation date, if it's a file or directory, you can recursively iterate. So now I have more intelligence when I go to browse these things in pipelines, and I'll show you how you can do that to be able to browse. And then you can also browse through the UI. So I can browse and pick files now. I don't have to guess at what's on the file system in the Docker container that's hosted in Oregon. So it's pretty nice. You can browse and all that through the UX. The other thing, so in the actual file connector now, I think this was in before we have encoding, so you can decide is it text-based or binary. Before we could only process files, so we had to actually physically move them. Now you can actually, I was using this before, but you can pick files that are newer than a date. So let me, instead of going into all the nitty-gritty here, let me actually bounce back and just show you a pipeline of something you can do that's pretty cool. So here I have, in a group, I have a move, I'm just calling it wasn't very creative, so move new files pipeline. This pipeline's too long in my opinion, so there's probably a few things we're going to do to optimize this in a future release. There's a few stages we could probably remove. But basically, essentially what the business problem I'm trying to solve is like, hey, new files that are CSV format end up in this directory, and I want to run this pipeline to detect those new files and send them to AWS S3 tables. So essentially, this pipeline is going to wake up every 5 seconds. And then what I'm using is this thing called pipeline state, which is I'm keeping track of the timestamp that I last ran essentially. And when I go and actually get the new files, that setting that I asked you to remind me to put back is where I'm passing in that time to say, I'm going to browse this directory, but only return to me files that are newer than this date. So I'm passing it to the browse input with this timestamp. And then from there, it's going to turn to me an array of files. And let's just, instead of talking to it, let's just run it. So we'll run this in debug mode, and you'll see I'm passing in the metadata. So this is my first run. So I'm passing in the year 2000. That's where I decided if there was no state in there. So that's going to get all the files. So this is going to go run the browse with the date 2000. Everything in there is not that old. So it's going to pull every file that's in there. the next thing I'm doing, this is one of the stages we remove. I'm just kind of removing this little files node. So I just get the array as a result. And then this is a breakup stage. So what I'm saying is I actually want to process each one of these files individually. So I'm going to break these up, and you can see it goes from 1 to 4 here. If I index, so each one of these files after this generates 4 individual events. And then in that event, I'm going to actually take the file that came in, and I'm going to go and read it. So I'm going to do IO to go read the file, and then I have success failure pass. And this is another stage we can probably get rid of where I'm doing a little value prep. And then I'm going to parse it. So this is new in 4.1 where we have these parsing stages. So you can parse CSV, XML, JSON, Parquet straight in the pipeline. So I know this is a CSV file. So what I want to do is turn it from this base64 encoded blob to a nice, pretty, JSON-like structure of, and you can see it over here. This is what's actually in the file, the data. And then I'm writing it out to S3 tables. And then the last thing I'm doing is I'm just updating that timestamp to say, okay, now that I've had a successful run, only grab new files later, older than that. So I've developed that. And when I break out a debug, you can see in general what this is going to do is this is run 38 times, but it stops here, right? Because there's no new files. But if I just, I hit the wrong button. No, we're good. If I just grab one of these files and copy it, that should show up as new. In the next execution, you can see it found a new file and processed it. And if I do want to restart the whole thing, I can just go into state. I can modify this state directly, or I can just delete it entirely. In the next run, it'll pick up all the files again. So I have some control through the UI of kind of resetting that logic. And this is the example, just using the new browse interface to find the files and put some more logic around what I want to process. At the end, I'm actually sending this up to S3 buckets. I was hoping to show this a little bit more, but you can see there's a table called Crusher that I'm writing it to. So all the data is landing there, but right now I'm just having some issues with Athena, which is the query editor. So I should be able to come in here and see a table called Crushers and query it as if it were SQL. So I could say, give me all the Crushers with this status or whatever, and it would run. But right now, I think it might be a permissions thing or whatnot. Something's got to go wrong in a demo. So you're not seeing the table right now, but that's the S3 tables capability where you can instantly query the data. I don't have to do anything else to it.
That's pretty slick, Aron. I think we can also send out, you have a nice demo video of that too. We can share it with all the registrants after this webcast too. So looks good. Let me jump back in. I have another question. So we've covered S3 tables, files. There's a lot of new features added for life sciences and oil and gas. I mean, yeah. Say there's been a lot of demand, particularly from batch and process industries for HighByte Intelligence Hub in the last 12 months. We've had features before. We've continued to add to it. So I think this is the last question I'll ask, and I'll turn it to Jeff. Can you tell us a little bit more about what we've added to the Intelligence Hub for these markets?
Absolutely. This is my particular favorite. I think this is a great example of the REST data server. So we have a number of life sciences, pharmaceutical users. Kerber PassX is a very popular MES in the pharma space. Has very sophisticated batch management capabilities. And it's very interesting about it as an MES where if you look in discrete manufacturing, oftentimes the MES is an endpoint and you kind of have your automation do its thing and you kind of invoke the MES for information or you post data to it. What's very interesting about in the life sciences space, the batch kind of rules everything, if you will, right? So the batch, so the MES reaches down to the automation layer and says, you must do this, or it tells people to follow certain procedures, right? But also it also expects that the automation transacts with it upward, if you will. So it's kind of interesting. Your MES is both a client and a server, and your automation is both a client and a server. So with callable pipelines, we can make this happen, right? So it could be something as simple as maybe I enter a new phase of a batch, or I need to, something happen and I need to gather new, let's say file data, just as Aron was talking about, right? I have file systems that aren't exposed or they don't meet the machine builder standard of the life sciences industry for whatever reason, right? They're not following the data standards, right? When that event happens, PassX can reach in and invoke a call within Intelligence Hub. Intelligence Hub can acknowledge that request, right? But it can extract out those parameters and then maybe reach into a file system or a historian, gather the necessary data, process it and shape it, package it all up, and then post that back, and then get acknowledgement on there. So you have very, very closed loop control for different life sciences and advanced MES use cases. The other scenario Aron already talked about is the IP.21 scenario. I'll say it's definitely relevant for life sciences, but the thing that we're also seeing is as people have had a lot of luck with Pi and they're using enterprise data platforms, Snowflake, Databricks, and so forth, right? People want to aggregate those data all into one place, and what they're finding is that's great what we just accomplished with Pi, but I have another business unit in a different continent, and they doubled down on IP.21 as an example. Can we replicate that there? And so this is a great example where having an abstraction layer or industrial data ops saying, regardless of the technology, regardless of the continent, regardless of the business unit, data is landing in a consistent schema in our enterprise data platforms, regardless of how chaotic or heterogeneous our environment might be. And then the last one that I'll quickly touch upon is audit logging, right? Industries such as life sciences, change management is paramount. It's very, very important. And one of the key ways of managing change management, or at least enforcing it and ensuring that it's actually being followed, is through auditing, right? We find that there's a lot of different options to configure intelligence hubs. Some users are doing it programmatically. Some people are taking more of a DevOps approach, where they're bundling configuration as files as they deploy the software. And then others are using the project APIs, right? We've now really, down in the core services inside of Intelligence Hub, really bundled auditing. So it's very, very granular. And we think that auditing is just important, not to just capture those events, but also to see the before and after of all those events that happen. So if someone updates a model, yes, it's important that we know when that happened, who updated, and so forth. But it's also important to see what specifically was modified. Not that model was modified, but what did they change the name of that attribute, right? And then the other thing that we have to consider about is cascading changes, right? If you have a model or a connection that is tied to many use cases or many things, right? That could be a cascading or a propagation problem elsewhere. We also need to know the downstream impacts of changing one thing. So we've thought very, very rigorously about this and how to accommodate the needs of regulated industries such as life sciences.
I'm stealing it from you, Jeff, because I got 4 minutes.
Yep.
And I never thought I'd make it this far, given how we started. So I just I want to do this. Yeah, I'll show what Jeff just said. So this is pretty cool. So we've had auditing. You turn it on. So now it's way more capable. So now if I jump into a pipeline, for example, and I jump into like a CSV stage and I change this to this, because it's just chaos, and I go to the logs, what you'll see is we have an audit event, which we logged before. But if I hit more here, you can see, hey, someone edited this pipeline, and the administrator did. That was me. And if I go down and I see, like Jeff said, this is exactly what they changed. Now I can go blame them. I could go back this out. Pretty cool. And what Jeff had mentioned with cascading, this is even cooler. So this file connection is used in a pipeline. So if I modify the name of this thing and I go to, again, back to the audit logs, what you'll see is not only did we capture the name change, we said, hey, this thing's modified in a pipeline. It was referenced in a pipeline. We updated that for you. So we show you the other tangential references that were changed. That pipeline was changed with the name as well. Pretty cool. That's the demo.
Awesome. Okay. Well, we are coming up on the hour. First of all, Ty and Ryan, thank you so much. You're both doing an epic job on chat and Q&A, keeping up. So thank you for that. I will also say we had almost 300 registrants for this webcast and received around 30 questions. We were only able to answer a handful of them live. So we have an amazing team of solutions engineers who will follow up with you after this if you took the time to submit a question and didn't get it answered live. But with 2 minutes, I have a question for Aron and Jeff, which is, we talked about everything we did. And so now what's next? Aron, you want to go first?
Yeah. So we're working on 4.2 now. Some big features in there. Get integration. So you'll see that, the ability to back up, use get, also like pull artifacts like model definitions from a Git repo and kind of merge that into the project. Another big one's open telemetry. So you'll be able to connect if you're using open telemetry into HighByte, and we'll be able to produce all the data on metrics and a lot of cool functionality. And we're just working on that now. And then there's a ton of other stuff. I mean, if you even look at the 4.1 release, it was big. I think 4.2 will be even bigger, more connections, more. Yeah.
Just another minor release.
Right.
The other snare I'd say is cloud to edge, right? Our users have been sending so much data to the cloud, and the lines have sort of blurred what is on-prem and what is in the cloud. More capabilities at reaching into those systems and extracting data out and using that on the edge.
Oh, and you'll see some AI stuff. So we'll actually have
you
connections
had to
there.
end with it.
AI connections for doing some of the tag generation. We have a demo of that. So you'll see that baked into the product with the ability to choose whatever LLM, if it's edge or cloud, to do that kind of stuff. So some cool functionality, and then just the ability to experiment with it, I think, for a lot of customers.
It's awesome. Thank you so much. Thank you, Aron. Thank you, Jeff. I know you put a lot of thought into these. I really appreciate it. And thank you for everyone who joined us today. Again, this was recorded. We'll get the recording out to you in the next 24 hours. And if anyone would like a copy of Jeff's amazing diagrams, let us know and we'll get those over to you too. So thank you so much, and see you soon.
Awesome. Cheers.